Hello and good day, pre-algebra. We are starting our next unit, Unit 7, which is all about percentages, and we're going to focus primarily these first couple objectives on the conversion piece, working from decimals to percentages, percentages to fractions, and back and forth, okay? Because, you know, percentages, decimals, and fractions are all kind of like cousins. You know, who's got cousins here in the school? I know some of you. Yeah. If you were to stand next to your cousin, you might not look a lot alike necessarily, but you're related. Okay. Kind of like, for example, the decimal 0.25. What is the decimal 0.25 as a fraction? Sarah? 1/4. What is the decimal 0.25 or the fraction 1/4 as a percentage? Anyone know? Pierce? 25%. Okay? All three of those things are related in that they have the same value. We can definitely see a connection between 0.25 and 25%, right? They both have a 25 in them. But the 1/4 looks completely different, but it has the same value. Right? That's what I mean by cousins, right? Look a little different, but related. So we're going to start with converting decimals to a percentage, the one that has that definite connection. So it says the first part of this unit is going to focus on the relationships between decimals, fractions, and percentages. As it turns out, they are all related, and it's important to know how to convert from one to another because different data sets may use one of the three forms more than the others. Money. If something is $3.50, that's as a decimal, right? Have you ever seen a price that is 7/2 of a dollar? No. Do those two things mean the same thing? Yes. Okay? So it's important to know, to be able to convert back and forth between the three, because if you want to represent a value as a decimal, okay, you have to know how to get it there. Right? So that's the rationale behind this. This number line here is going to kind of be our decimal to percentage guide. We're going to start with a decimal value of 0% and end with a decimal value of 1/2, or also written as 1.00. What percentage is 0? If you have nothing of something, what percentage of that do you have? If you get 0 out of 30 on a test, what percentage did you get? And I got 0%. Okay. If you get all of something, you have 1/2. What percentage did you get? You get every question on a test correct. What percentage? 100%. Right? Okay? And that's why percentages typically stay within that 0% to 100%, because either you have nothing or you got everything. Okay? And there are times when you might get 105% on an assignment because of extra credit or whatever else. But generally, percentages, the word percent means out of 100. You either have nothing or you have everything. So if you got 50%, roughly half, what decimal would 50% correspond with? If 50% is halfway between 0% and 100%, what decimal is halfway between 0 and 1/2? Kira? 0.5. Or, to kind of relate to that 50%, 0.50. Right? And let's also mark 20. I think the directions say divide into tenths. We're just going to kind of divide it into fourths instead. 25%, we already talked about that. Decimals being 0.25. And then 75%, what decimal would that one be? 75%, kind of look at the other examples here. What decimal would 75% correspond with? 0.75. Okay. And it's not a coincidence that our decimal goes out to the hundredths place here, right? We would read this decimal as 75 hundredths. The word percent means out of 100. So 75 hundredths, 75% They mean the same same thing. Okay. So go ahead and I'll switch colors. You'll go to red. Mark down where on this number line. Just put a dot where 30% would be. And then label it 30%. And then go to 0.65. Where would 0.65 be? And label it. And so on and so forth. Okay, I'll give you a minute to do that. We'll pause the video briefly and we'll come back. All right, so placing 30%, you should have it kind of somewhere right around here. And if we label that as 30%, the decimal value would be what? The decimal value of 30%. Aiden. 0.30, 0.30. You might also see it as just 0.3, right? That second zero isn't necessary, but just so we can definitely see that connection between 30% and 0.30, then we have it there. 0.65, probably going to be right about here, okay? 0.65, what percentage does that correspond to? Aiden. 65%. 65%. 99%, that's going to be tucked right up next to that 100%, which if it's 99%, what's the decimal value of that? Anybody? Everybody? 0.99. Okay. 0.08. 0.08. Now that does represent 8 hundredths. That 8 is in the hundredths place, so it's going to be way down here. If you put it up in this area, then you interpret that as 80%, which would be 0.8, not 0.08. That zero matters because it's not at the end of the decimal, it's in the middle. So 0.08 is going to be down over here. And what percentage is that? Everybody? 8%. Okay. 25%, we already have that one marked. 100%, we got that one marked as well. And finally, 0.82 is going to be, well, right about here. Right. Which, what percentage is 0.82 going to be? 82%. So hopefully you can definitely see the connection between a percentage and a decimal, because both represent being out of 100, 65 hundredths, 65%. That relationship is pretty apparent. Okay. Down below here, a very common mistake that folks make, that maybe some of you made with this 0.08 here, it does make a difference where a zero and a decimal is. In 0.08, that decimal matters. It has to be there because that's what puts the 8 in the hundredths place, which is why this is just 8%. Something like the next one, 0.1, we could put a 0 on the end of that, but it's not necessary because whether that 0 is there or not, the 1 is still in the 10th place. So 0.1 is going to be 10% rather than 1% because the 1 is in the 10th place and 1/10 is 10%. If we put that 0 there, that's pretty obvious. Oh yeah, 10, we got a 10% there. But since it doesn't have to be written, sometimes if you're kind of working too quickly, you see the 1, you think 1%, but it's actually 10%. What about this one here? 7% or 70%? 70%. That 7 is in the 10th place. We can put the 0 there to make it 0.70 if that helps you. Put it out to 2 decimal places. Okay. How would we write 3% as a decimal? Would that 3 go in the 10th place or the hundredths place? Ifan? The hundredths place. 3% would have to be 0.03. There, the 0 is necessary because it's what puts the 3 in the hundredths place. How about 60%? 0.6 or 0.60 or 0.06, I mean. 0.6 or 0.06? Alina? Sorry? 0.6. That's 6 being in the 10th place. If we put the 0 on, great. Then it's very clear. 0.60, 60%. Okay? But you won't always see it there because it's technically not necessary. Questions on this? Okay. I'm going to give you 5 minutes to work through this page here. I'm going to come around and check off that it is finished before we go on to the next objective. The one thing I want to mention that we didn't talk about up above, something like this. What percentage would 1.56 be equivalent to? Noticing that we have a whole here, right? We have one whole and then 56 hundredths. What's that going to look like, Annika? 156%. How about 1.3? What would that be as a percentage, Kira? Good, 130%. Some of you might be sitting there thinking, oh, hey, wait a minute. If I just kind of take the decimal point and move it over to the right 2 times, that's my percentage. 156%. This one would be 92%. You're not wrong. It's exactly what's kind of happening here. Okay, that would be 92%, yeah, 92 hundredths. So 5 minutes to do this. We will go over answer shortly, then we'll move on to CO50. Back to it. Let's go over some answers here. Question? Yes, the brain busters at the bottom. We will talk about those. 0.22, 22%. 0.3, 30%. 0.71, 71%. 0.05, 5%. 0.2, boys, 20%. Bottom row, 0.5, 50%. So different from the 0.05 we had up here versus 0.5 here. Okay, one is 5%, the other one is 50%. It depends on where that 0 is. 0.21, 21%. 0.01, 1%. 181%. Since we're greater than a whole, we're greater than 100%. Same thing here. 1.5, 1.5, 150%. 99% for the next one. Hey, how many McHummerton? Whoever is doing that? Woof. Okay. And 0.37 is 37%. The 3 down below, we already kind of talked about this second one here. Write a decimal that's between 84% and 85%. The decimal, 84%, 0.84, can also be written as 0.840. And 85%, 0.85, can also be written as 0.850. So what did you come up with as a potential decimal that's between 0.840 and 850? Yeah. 0.841. Right? Which as a percentage would be 84.1%, which is between 84% and 85%. You could also have 0.842, 0.843, 0.844, 0.845, etc. Right? But that's kind of how you would attack that one there. What's a percentage between 1.66 and 1.69? What did you come up with? Yeah. 167%. Some of you may have had 168%, right? 1.66 is 166%. 1.69 is 169%. So those would be probably the most common percentages that folks wrote down as being between them. And lastly, what did you come up with for 3 types of data for which a decimal is most appropriate? We already talked about money. What else? Sarah? In math. Sure. Yes, there are certain math instances where if we're solving for a variable perhaps, and we get the variable to equal 0.8, and I asked you, what's the value of x? You said 0.8. Someone else says x is 80%. Technically, you're still right, but we would use the 0.8. Sure. What else? Yeah. On a test? How so? Typically, I guess maybe some teachers use decimals. I go more in fractions, but potentially it's possible. Yeah.
Like if you're doing a competition and then they're like, oh, you got 10.5.
Sure, timing, right? Those of you that do basketball where the clock goes down to tenths, right? That's in decimal form. When you're racing, swimming, track and field, that's recorded in decimal times as well. Excellent. When you're playing games, certain games, anyone in particular that you can think of?
There's that one game that's called like Paper.io, and you have to it shows the percentage of how much you filled up with like a map.
Oh, fun. Yeah, okay, good. Anna. Sorry?
Like the
Nutrition fact labels. I have seen decimals on nutrition fact labels before. And they also use percentages very, very heavily too, right? Because they tell you how much of something is in it and then what percent of a 2,000 calorie diet that works out to be. So yeah, they're out there. They're out there. Good. Questions on CO49? Okay, moving ahead then to CO50. And we are still recording, so please keep your voices at a good level. CO50 is converting a fraction to a percentage. And we've already defined percentage in CO49. What did I say the word percent means? What did I say the word percent means? Yeah. Out of 100. Okay. Percentage means out of 100 or per 100. Okay, it's not a coincidence that pennies are also called cents, right? Because it takes 100 cents to make a dollar, make a whole. Okay, so per cent, out of 100 or per 100. And we can use that to help us with percentages and fractions, because out of 100 means that any numerator over a denominator of 100 represents the percentage. What do I mean by that? This fraction here, there are a couple different ways that we can say it. We can say 27 hundredths, or we can say 27 out of 100, right? 27 out of 100. And since percent means out of 100, this literally means 27%. Notice how the percentage sign has kind of like a 1 and 2 zeros? 100? I don't know. Quinky dink? Maybe, maybe not. But it works. 35 hundredths, 35 out of 100, what percentage is that? Anybody? 35 out of 100, what percentage is that? Everybody. 35%. 90 out of 100. Everybody. 90%. 29 out of 100. Everybody. 29%. 3 out of 100. Everybody. 3%. 189 out of 100. Everybody. 189%. Okay? When that denominator is 100, it makes that correlation between fraction and percentage very easy, very apparent. However, you look down the page in the homework section and you see, there are a whole bunch of fractions there that don't have a denominator of 100. Okay? Which is why we have what are called friendly denominators here. And these denominators are friendly because we can get to 100 pretty easily from them, right? For example, looking at this first one here, 3/5. This is not 3% because it's 3 out of 5, not 3 out of 100. However, how do we get from 5 to 100? What's the scale factor? Multiply by 20. right? It works out evenly. So if we have to multiply this 5 by 20 to get a denominator of 100, what do we have to multiply the numerator by? Here's 20, which gives us a numerator of what? 60. Now we're in business, right? Because now we've got something out of 100. So what percentage is 3/5 or 3 out of 5? Alexis? 60%. Because it's equivalent to a fraction that's 60 out of 100. And so if you start to look at these denominators here, you'll notice that all of them, you can get to 100 pretty easily, pretty quickly. Until you see 4/9, right? Like, wait a minute, 9 doesn't go into 100 evenly, okay? But a number like 9, true, we can't get to 100, but we can get to 99, which is pretty darn close enough for our purposes to be 100. So for that denominator of 9, 4/9, we'll be multiplying by 11. Someone should go check on them. To get us a denominator of 99, which, like I said, is it exactly 100? No, but it's close enough. So that when we multiply by 11 up top, and we get the fraction 44/99, we can say that this is 44%. Okay? The other denominators that get you close enough for our purposes, 3, you're going to multiply that by 33 to get 99. 11, you're going to multiply that by 9 to get 99. 33, you're going to multiply that by 3 to get 99. And all the rest work out perfectly. Obviously, 1, you're going to multiply by 100 to get to 100. 4, multiply by 25. 10 times 10. 25 times 4. 2 times 50. 20 times 5. And 50 times 2. You'll notice that these friendly denominators are a key point because you will not be able to use a calculator on the test. Okay, on this section of the test, your test will be two parts. All 4 conversion objectives will be non-calculatable, non-calculator. You'll turn that section into me when you finish, and then you'll get the calculator section. Okay, so this objective will not have a calculator on the test. So it's important to know, how do I get from 11 to 99, right? And so if you need that multiplication, put this on a help sheet, this key point here. Okay. All right, go ahead. In the next 5 minutes, I'd like you to do the rest of this bottom section here. Convert these fractions to percentages. When you're done, I'll come around, take a look, and that's your ticket out of the room today. Okay, your ticket out of the room today is this section completed. Yes, Sarah? Oh, excellent. Okay, I'll come around shortly. If you have your hand up because you're done, you can put it down. I'll come around. Questions only. Yes? Okay. Questions on what you are to do? Okay. No homework for the weekend, but your ticket out of the room is to finish this page. So that's what you are to work on now. That is how you math.